Welcome everybody, I hope you are well and safe. I am Mohamad Abdallah and today I will discuss the TCICA test. It is experiment number 10 and it is page 271 in the Schreiner book. So as a general overview of today's video, I will explain the main uses of the TCICA reagent and how it is made. I will also describe this test and what functional group identifications can be made from the results. I will explain and go over the controls, the positive and the negative control, and how to clean up the process, and to list the mechanism and to list other uses of the TCICA reagent. The TCICA tablet, also known as the trichloroisocyanuric acid, is a chlorine-based disinfectant used widely for water treatment in swimming pools. Now, this compound is usually available in the form of tablets as shown here and releases chlorine to sanitize water and control algae and bacterial growth in swimming pools. Now, these tablets are usually preferred over other traditional chlorine sources because of its extended disinfecting effects, its ease of handling, and its of high stability. So in order to do or prepare the TCICA reagent, as structure is given here, we need to dissolve 0.3 grams of the TCICA solid in 10 milliliters of acetonitrile, shown here. And it is important to mention, in order to maintain the stability of this reagent, it should be stored in a brown bottle, and the tablet can be purchased from any swimming pool store. So in order to talk about the TCICA test, first I will talk about the procedure. Now for the procedure, we need to add 0.5 milliliter of the TCICA solution. We need to add 1 drop of 1 molar hydrochloric acid HCl and 3 drops or 0.04 grams of your unknown, depending on the physical state of your unknown, to a test tube. Now the general overview of the reaction is shown here, where the trichloroisocyanuric acid reacts with alcohol, aldehydes, or ketones in order to form this white solid called cyanuric acid. Now, the formation of this white solid is a positive test itself. However, what is important in this test is to record the time needed to form this cyanuric acid, because the time needed is what will help us identify the functional group we have in our unknown. Now also it is worth noticing that TCICA is a very strong oxidizing agent. It is shown here because the nitrogen now was bonded to chlorine and now is bonded to hydrogen, so it is being reduced itself and it induces the oxidization of the other species present in the test tube. So to shift our focus onto the control tests, we need to conduct both positive control tests and negative control tests in 2 different test tubes. For the positive control, we can use either 2-propanol, butanol, phenol, or ethanol. And for the negative control test, we can use 2-chloro-2-methyl-propane. As you can see, in order to clearly see what is the color of the precipitate that will be formed for the positive control test, as you can see here, it will be a turbid, creamy white color, as you can see here. However, for the negative control, it's going to be the pale yellow color, as you can see here. And for the YouTube link where the instructor clearly shows how to perform the test, I've provided the link over here. For the discussion of results, the time required for the white precipitate to form is of importance and helps us identify what the functional group present in our unknown is. Primary alcohols react in 1 to 15 minutes. Secondary alcohols, on the other hand, react way faster in 0.1 to 1 minutes. Tertiary alcohol needs 5 hours. Ketones do not react within 4 hours. Aliphatic aldehydes react in 1 to 1.5 minutes. However, aromatic aldehydes react in 2 to 3 hours. Phenols need to react in 1 to 15 seconds. Sugars need 1 to 5 minutes. And cholesterol needs 10 to 40 seconds. In order to understand why primary alcohols and secondary alcohols react differently, I will discuss this in the next slide. In order to better understand why the TCICA test is mainly used to distinguish between a primary and a secondary alcohol, we need to discuss the mechanism. Now, we have already discussed that the TCICA is a chlorine-based oxidant. It will provide a chlorine which will interact with the hydroxyl group of the alcohol. The oxygen here of the hydroxyl group of the secondary alcohol will act as a nucleophile and attack one of the chlorine atoms in the TCICA. This interaction will then form a chlorinated intermediate as shown here. As a second step, in the presence of pyridine, there will be a proton transfer. Pyridine will act as a base and it will abstract the hydrogen of the secondary alcohol, leaving a carbocation intermediate. Now here comes the discussion of why a primary and a secondary alcohol differ in their oxidation rate with the TCICA. The additional electron donating effect from the alkyl groups of the secondary alcohol make the intermediate much more stable, and it will allow it to proceed more rapidly than a primary alcohol. Now after this step, there will be a formation of a double bond between the C and the O, and the Cl will be kicked out and will be present as Cl- in the solution. There will be a formation of a ketone, of a protonated pyridine, and of the modified TCICA structure as shown here. It is worth mentioning, and we will later discuss it in the next slide, that we will need 3 moles of the secondary alcohol in order to remove the 3 chlorine atoms of the TCICA. After the addition of the 3 moles of this secondary alcohol, the TCICA will be fully reduced into the cyanuric acid. So in front of us is the general reaction of the TCICA test. I want to talk about 2 things in the general reaction. The first thing being the product. The product here is a ketone when the unknown was a secondary alcohol. And another thing I want to talk about and mention is the presence of 3 moles of secondary alcohol. Now, we previously discussed in the mechanism that we need 3 moles of the unknown, or in this case the secondary alcohol, in order to completely reduce the trichlorocyanuric acid into the cyanuric acid. As you can see here, all these 3 chlorine atoms have been replaced by the hydrogen atoms. Another thing I want to talk about the general reaction is the cleanup process. So in order to clean up, we need to add a few drops of 2-propanol or a few crystals of sodium hydrogen sulfide to the test tube. This will ensure that any unreacted TCICA will be reacted and destroyed. So other uses for the TCICA would be the reaction between an aldehyde, methanol, and a trichloroisocyanuric acid. This reaction of the aldehyde in the presence of methanol and the TCICA is believed to form an intermediate hemiacetal. This hemiacetal will then rapidly be oxidized in order to form a methyl ester. So this use mainly will be to produce this methyl ester if necessary and if needed. So with this, I conclude my video about the TCICA test. Thank you very much for listening, and I hope this was very clear and fruitful.